Hi, good afternoon, everyone. My name's Will, and I'm here with my colleague Ian from the NOC, and we're going to show you some funny photos of what we did to build the network here. So, what's the network actually for? Here is our vision, our strategic goals, and all that blah. We wanted to give everyone gigabit, really, these days. Some decent Wi-Fi, which has worked pretty well, and also in line with our aims of having basically properly provision enhanced connectivity, filter-free, net neutrality, all those things you hear in the papers these days. And we wanted to have a lot of fun while doing it and maybe top our tans up. So how do we design this? Well, we have an intersection team which goes and does various hacker camps. So it means we kind of run different size networks every year almost these days. But this is the biggest one ever, obviously. We had 37 Darden close, which is maybe 15 more than the previous time we've done an event. 47 fiber cables laid across the fields, totaling 7.2 kilometers. 78 edge switches. And just over 100 wireless access points. We decided to run a collapsed core for this event to reduce interdependencies, so everything, as much as possible, goes back to a central location. So this site you see all around us, I mean, it has a great industrial history. That means there's actually damn train tracks everywhere, and unknown underground services, and one of the problems appeared during our planning for this event is that we weren't able to, without lots of special measures, to really go very deep into the soil because there's unknown cables, and there are really quite a lot of train tracks as well, which make running cables difficult. So we didn't do this. We did, however, manage to do this during the build-up. Fibers do not generally survive being run over by a train, and this one is kind of broken. This was due to an accident, basically. Anyway, no harm done there. So this actually all required quite a lot of planning, and we did this in a lot more depth than previously. We teamed up with the VOC for planning in OpenStreetMap. We then were able to do a lot of automation of the cable selection and putting the right cables in the right places using OpenStreetMap API and some tools we built ourselves. And a side effect of having all that information available is that it was then publicly available to you guys, so you can see where the Darden close are if you look at the camp map URL. And it enables us to check the design properly and generally sort of make sure that we don't spend ages pulling a cable to find it's 5 meters too short, which is really super frustrating. Here's a plan extracted from that of the site. You probably won't be able to see it because the site is quite large, and but you can check this online. But you can see our main cable routes across the site here, which are the green lines. And really, we wanted to get to everywhere that you guys occupied. And here is another diagram you won't be able to see, which is our physical infrastructure. And what we actually do is have a lot of multi-core fiber cables which are connected together. And what this means is that basically we have light paths all the way from, say, an edge Darden claw all the way over there back to the NOC data center. It means that if there's any, for instance, problems with power or similar or equipment in a more peripheral location, then that won't have as large an impact, and then therefore makes the network more reliable for you guys. Uplink. Well, we had to get the internet here. We spent some time on this because as you have traveled here, you know that this place is quite remote. There's not a great deal of infrastructure, but then we found actually about 2 kilometers that way, there is a large high voltage line, and using our contacts, we were able to get those guys to give us a 10 gig wave back to Berlin. which is great. And is, to those of you who've seen our presentations about Congress networks, meant we could do much the same thing. So yeah, there's a splice enclosure on a pylon. This is it, about 2 kilometers from the site. But it wasn't all that simple, because there's a river there. There's also a lake the other side. So we would have to carry the fiber quite a long way. So we used a lot of this lightweight fiber, which actually 2 kilometers of this only weighs 20 kilos, so you can actually pick it up and carry it around. So we had to cross the lake. Our experiment showed that the canoe, the 2-man canoe, was actually better for unrolling the fiber than the rubber boat, because you could just put this stake through the spindle and unwind it. So yeah, canoes seem pretty good for that purpose. So yeah, we had an interesting time. I can't actually use a canoe, so yeah, it took some time. We, of course, yeah, here is the fiber in the canoe, and we had to do, obviously, some splicing out in the field, so there's quite a lot of sitting, getting stung by insects and all that kind of stuff. A lot of you know about the rodent damage. In fact, I have some of the offending pieces of fiber here if anyone wants to come and have a look at them. This obviously this had quite some coverage, and lots of people found this quite amusing. What we actually did to mitigate this was we went along in this stretch where these animals live, and we've basically invaded and hung the fiber up higher in the trees, so we weren't really obstructing where they go. But yeah, it's pretty easy with this thin fiber for it to be damaged by rodent activity. So back to technical stuff. Layer 3 design. BGP Edge with a pair of Juniper MX104s in Berlin and here in our NOC DC in the Ziegler Park. And then we dusted off a very venerable Force 10 E600 that I think was last used at 29C3, 28C3, but did a good job there, and actually was just what we needed here, so why not? We did the usual, we used a CCC address space for IPv4, and then a temporary /16 from the RIPE NCC, and of course v6. It's pretty much the same as last time. Just a few photos from the NOC DC. We actually even managed to label stuff this time. Edge. So we rented a lot of HP ProCurve 2530 with 24 gig ports on the front, and then uplink those into the core with 2 times 1 gig E. These are single fiber optics, so they use 2 different wavelengths on the same fiber, and that reduces the amount of fiber that we need to pull around the fields, and also makes troubleshooting easier. For some locations, we wanted to provide 10 gig E uplinks, so we used some Juniper switches there. And we were testing some other hardware as well, Cumulus gigabit PoE switch with 10 gig E uplinks and some Huawei switches as well. So we actually, although the bulk of the equipment was the ProCurves, we have been using some other stuff as well. Data center, it's often a pain doing this. It's been damned hot here, as many of you know, and really it's been that way for the past few weeks. So we have a DC container with the NOC and Vox services, and the uplink actually terminates in there. We had lots and lots of aircon problems. In fact, we started off with 2 aircon units, and we ended up with 7, which is more than the number of switches we had in the place. But yeah, at least it stayed cool there. I'll move over to Ian for the Wi-Fi.
So Wi-Fi. We've been using a similar setup as at this last Congress, which was a dual Aruba controller running in a high availability setup. We've deployed over 101 8211N and 8211AC access points. and that had an average of about 1.5 access point per dot enclosure. So we would mount one access point in dot enclosure, and then we have another, like a more outdoor suited IP65 access point, which in the neighborhood to cover the edges. Because what we see is that around the dot enclosure, we have around 30 meters of good coverage, and then we still need to fill in the other gaps. So we used a couple of outdoor access points. So you might have seen them hanging around at several places. These are the access points which look a little bit like security cameras, the big white dome access points. And we are deploying multiple access points in the track tent and workshop tents like this to have more capacity, because in a room like this, there's like, 500 people there, so one access point doesn't cut it, so you need multiple access points to have enough capacity. So we had a peak of 3,300 associated clients, and we did around 1.25 gigabits. That's RX and TX aggregated. We've seen around 10,000 unique devices. So that's what we've seen over the last couple of days, and that's not concurrently online on the network. So. Yeah, we were running, like at Congress, 802.1x again. So people could use a random username password to log into the network. And so on the left side, we have a nice top 11 there, and then you can see why we made it the top 11. So. So the device types on the network, it's mostly smartphones. So you can see that Android and iOS are in the top 3. So that's a large bit of the network are all smartphones. And then other than that, we have, of course, Linux devices, and then as we would expect at CCC, that this Windows is being very, very low used. So that's good. So, regarding the type of devices that connected to the network, so we more than 50% were actually 5 gigahertz capable, so that's pretty good. Last Congress we did, I think, around 65%, but yeah, it's good that we have more than 50% of devices actually being 5 gigahertz capable, and we're also seeing quite a lot of the newer generation devices, the 802.11ac devices. That's already 21%. And regarding the usage of the SSIDs, about 42% of the devices were on 802.1x. That's a bit less than at last Congress, but still pretty okay. So if you want to have some encryption on the Wi-Fi layer, then yeah, use 802.1x. More pretty graphs. So this is a graph where we are plotting the number of associations per field or per region, and you can see, I'm not sure if the mouse pointer works, but you can see over here that the green lines, this peaks over here are actually the people getting in and out of the track tents. So we can pretty much see that if there's a good talk going on in a tent, so if there's lots of people there, then it must be good. And then at some point, like during the night, we see people going to the east side of the camp, which is where the bear village is. So people are going to the bars and yeah. Yeah, and you see the red line over here. That's the central Platz, where also the bars are. So it's pretty obvious where people are going. So the lightning storm yesterday. Yeah. So we obviously have a lot of stuff missing here because we had to power down the DC. All the generators actually got turned off. But it's also interesting to see that the people were like moving they were getting into the big track tents. That's the blue line over here, and then people were moving to the Centralplatz. That's the red line over here. So it's also interesting to see what's happening when you're having a situation like that. So challenges. yeah, we had to make a bit of a trade-off between coverage, capacity, and performance, because it's a very open field. So it's and there's not a lot of attenuation. So you don't have there's a quite large chance that access points will end up on the same channel. So we don't want to mount the access points too high, but then if we mount them lower, that could actually mean that we have less coverage. So that we need to make these trade-offs to get something working. And we did end up having quite a lot of high channel utilization in some areas. So that's actually the amount of time that the radio in access point is busy receiving and sending traffic. And once that channel gets more and more loaded, it will just slow down. And at some point, could possibly break, that you will not even get an association anymore. So we had some radios that were averaging around 65% channel utilization, which is very, very high, and peaking at 95%. Another issue we were facing is that there were a lot of rogue access points around, and that caused some devices to have some roaming issues, because the device will receive so much BSSIDs. If you're, for example, in the Centraalplatz, you can see very, very much BSSIDs around you, and your Wi-Fi device at some point will have some issues selecting the correct network, because it's receiving so many beacons and so many probe responses. So in the future, we would like to use some more performance monitoring using Wi-Fi probes. So we're looking into a solution for that, so we can test the performance of the Wi-Fi network just independently of the Wi-Fi infrastructure itself. So we will have a couple of nodes connected to the network, which are doing periodic speed tests and latency tests, so we can better signal at which areas the Wi-Fi would be bad. So. Another problem we were facing is that the space blankets that were put around the data enclosure actually caused a drop in 20 dB of signal attenuation. So that was very, very significant. So at some point we had to remove the space blankets again to increase the signal on the field. Yeah, and here's another graph that actually shows the 5 most busy access points with the channel utilization at 5 gigahertz. So you can see that there are access points that are peaking up to 90% channel utilization, even in the 5 gigahertz band. And that's near DK, Utrecht, Hamburg, and, well, one of the access points in this track as well. We had another tweet today, which was pretty funny. So somebody's geolocation was a bit fucked up. So yeah, this was because most of the access points here, they've been used at a conference. It was actually a Hack in the Box in Beurs van Berlage, Amsterdam. So that's the reason why. Yeah, his location showed up as Beurs van Berlage, Damrak, and there's some sex shops around. Yeah. So you want to take this one? Yeah. Okay.
So we didn't actually produce any, I don't think we produced any use more bandwidth signs this time around. The uplink did get used quite well, peaking at 7.5 gigs out. So we're pretty happy with this. Next time around, I guess we'll need more, because we always need more. We also did some instrumentation of what happened inside the camp, and saw like a maximum backplane capacity on the E600 of 22.5 gigabits. So there's quite some traffic flowing around the site as well, which is nice. We did a new dashboard which you can look at, and we're always eager to add more stats to that. We added some temperature sensors from the ICMP village and some other stuff. So yeah, more to come there. And I mean, it just shows. Here I've got a screenshot. It's number of wireless users and speed and traffic used by the visitors. All very shiny stuff actually. Ticketing. We used OTRS for the pre-event, which is kind of a historical thing. And then for years we've always used Roundup on site because it's just really simple and like people can just get started straight away with this. We only had 51 tickets have come through, which is quite low, I think, actually. So thanks very much to the NOC help desk for fielding the end user queries and doing all the unplugging and stuff. You may notice we had some lights on the Dadenklo. These were originally from the OM 2013 event, but they're actually very useful for us to diagnose any network problems. So they had this interesting kind of thread.
Oh yeah, so somebody at DK Dublin was complaining that the lights on the LED poles on the Datenklo were too bright, and yeah, they asked it to be switched off, and we were like, well, at least our Belgian colleague here said that yeah, stars are down, team has been dispatched, ETA 10 light years. So.
So what's the team actually behind this? Well, it's actually quite a lot of people. Like more than 30 people in 7 sub-teams. Of some of them quite young and some of them rather old gits like me. And we really started on site 2 weeks ago and 1 day today. So I actually arrived here 2 weeks ago to start with the uplink stuff. And then, yeah, as I said before, the info help desk were dealing with a lot of our end user queries and that sort of stuff. Actually, a lot of the equipment and services we use for this event can't really be bought commercially. Either it costs quite a lot of money, the commercial rates, or it's short-term stuff, or you need to borrow equipment and people just don't lend this stuff out. So we actually really rely on a lot of people who give us stuff for free. So yeah, really thanks to our uplinks, KPN Strato and Sys11, Ediscom who supplied the 10 gig wave to Berlin, eKicks and Speedbone for housing of the Berlin side of the operation, and then quite a lot of hardware from Bibil, Cumulus, SecureLink, Aruba, and Flex Optics. So really thanks to those guys for giving us quite a lot of equipment, and yes, we will send it back. So, well, goodbye. The network in the camping fields will be torn down starting about 1900 today, after the closing presentation. We will have everything kind of gone by 10 a.m. on Tuesday. So please be kind to our fibers as you see them in the fields, because we want to roll them up and use them at the next event. So thank you very much. Yeah, I get to do this, yeah. So I probably have time for a couple of questions. If anyone has some, come up to the mic. Is there a mic? Yeah. Oh, yes, the mic's here and here. I can't see anything up here. First up on my left.
You mentioned that you got the fiber to the electricity pole. But was the fiber to Berlin already included on the network, or did you need to add it?
Actually, there's an electricity substation at really near Zedernik, just down there. So the end-to-end, like the actual photons, as it were, go as far as Zedernik and go into their DWDM equipment there. So the actual physical splice through piece of fiber is about 6 kilometers to camp, and then it is transponded there. It's too far really to light as well. So it's not a physical pair of fibers all the way to Berlin. It goes into an optical network, which is pretty standard really. Do I see any more questions? No, then thanks very much. I'll pass over to the VOC.
I don't know how to use such a device with an apple on it. If it had a penguin, I might be able to get it running. yeah, that looks pretty nice. So it's really, really cool to see that tent filled with people wanting to see what we build and how we build it. Oh, it's running automatically. Interesting.
Oh, you just, yeah.
And maybe can pause it. Thank you. So it's nice to see the tent being filled with people like that. But as you may know, there are a lot of people on the campsite tearing down their villages or already on their way home, or some may even not have been able to come here in the first place. And we want the great experience you have here at least a little bit shared with them. So we are the WOC, and we are providing recording and streaming for the lecture halls and a little bit for the music on the field. And you may have seen our small and larger cats standing all around here. So the WOC here is not alone. We don't have enough hardware to do an event great as this or like the Congress, and we always have helpers. And this year we had like the AGS and a guy from iSystems here who provided hardware and also a lot of support, and both of them run one of the big tents. And we really like to say thank you to them, because without them that would not have been possible at all. So, as you might have heard, the action is intense here on the camp, and tents are a little bit more complicated than like a full operational Congress center. So, the day we arrived here and tried to build our stuff up, we had like a tent with no walls and no floor in it. And so guys from us started climbing around and hanging all the screens there and the beamers, and actually, you may have noticed that the tents stayed like in the skeleton state for quite a bit of time, and that was not really planned like that. So between the build-up team of the tents finishing the tents and we are setting up the audio-video equipment, there was like 0.125 days, so only some hours, and it was really, really hard to get it all done up until the opening event. But we managed to do it, and it was really hard for the team. So in the end, give the team who's not here on the stage a really big applause, because they really, really worked hard to get that done. So we have three main stages here. We have both tents, north and south, and yeah, their names are a bit complicated. They switched places sometimes and also got new names. So there was a little bit of confusion there, but in the end we managed to make it. And we also had the bear stage in the Berlin village, which did a really interesting program. And those were the three main stages we were working on. And additionally, we had our container, one of the OC's container. The NOC had one similar. You can see it on the screen. But the POC did it right, and they had like a big tent and a lot of space to party. So next year, we will try to learn from, in 4 years, we will try to learn from the POC. As you can see, we have a lot of hardware there, but the main device is standing in the DC. So what we have in our container is those really nice tele lights. They don't only show the time, but whenever something happens, like a talk starts or talk finishes or one of our encoder processes stop working, they will blink and display a message what's happening, and they're used via over the air, so we can carry them to the different locations we're going and always be notified. And also we have this really nice blinking light underneath it, which actually makes a sound when it's turning, because it's that crappy, but you can hear when something goes wrong, which is also really good. So what we have in the DC are two new devices that we bought in the beginning of the year. We call them the Minions because they're really small. They're like 10 centimeters wide, but they're really, really powerful cores. They have like 3.9 gigahertz i7 cores, and they did the whole encoding for the master HD files for the whole campsite. And at least half of the talks they did even twice, because we missed something. And those are the two devices who are actually producing the files you are downloading and viewing in the browser, at least most of them. And these are really, really nice devices, and I really like them because they're so small, you can carry them around with you, no problems. We also have a bit of interesting gear standing beneath the ceiling of one of the buildings in this direction, the one with the high chimney. We have Rohde & Schwarz transmitter equipment for FM radio and DVB-T and DVB-T2, I think. And these are really interesting devices, and we have played quite a lot with them. Actually, you might be you were even able to listen to the talks going on here and the special radio while you were driving around Sedinnik and doing your buyings for your village. And the DVB-T also had a lot of special features, like we had EPG running after some time, and even managed to get, oh, is there a slide missing? Oh, I think there's a slide missing. We had even teletext working and like a Twitter feed on teletext and this. But we weren't able to finish that as fine as we wanted to. Like, we wanted you to be able to enter your own teletext sites and send them out via DVB-T, and we are really looking forward to get that working at the next Congress, so everyone can have their own teletext website then. So another thing, like FM transmission is pretty old, and we like the new stuff. So we had guys from the Open Digital Radio project bringing DAB+ transmitters there, and they also managed to stream slideshow versions of the video via DAB+. There are not that many radios out there that can receive that, but they brought us one, and it seems it actually worked pretty well. So maybe it's really the future. I think, maybe-ish. So yeah, there were some special projects we have been working on, like when the thunderstorm was announced, the CERT asked us if we can do a video explaining to the nerds how to secure their tent. And as you may have seen, there were some tents that were really in need of a little help there. And the thing is, we used that video, we reproduced it, and cut it, and then we uploaded it to our storage. Like, we have a mirror of video files on the campsite, and went away. And when we came back and looked at our graphs, they kind of looked like this. And what you see there is like 1.2 terabytes of traffic produced by this single file. And we were like limiting out our 1GE link. No, it's actually, yeah, it was peaking like around 1.2 gigabits per second for an hour or 2 hours, because everyone on the campsite was viewing that one video. And looking at the connection stats, we saw like 50,000 people watching that. It's like crazy. And we were not really sure. It might have been a software bug of someone's notebook downloading the file over and over again, but even then the numbers are pretty awesome. So as I'm talking about the stats, we also have a nice dashboard, and it's actually the same technology as you have, but ours is not public, I think. And as you can see in the top row, we peaked like at 2 gigabits per second with the streaming. So that's all streaming relays added up. The one on the campsite, we have a local relay here, as well as the ones in the internet. And that's actually not that much. Like on the Congress, we were like around 17 gigabits. But hey, okay, it's about the sunshine and camping. And yeah, I know you're likely not to watch the streams, but there were great talks. So maybe you should take a look at the recordings then. We peaked like around 600 viewers at all stages, but the biggest stage was actually the bear stage, with about 400 viewers watching a podcast there, and it was more than the peak at the tent. So yeah, actually it seems to be the bear stage was more interesting. Looking at the stats, we had like 2 relays on the internet and 1 here on the campsite. And we did split routing and split system so that people watching on the campsite got their traffic from the relays here, and people watching from the internet got their traffic from there. This year we used HTTP all to the way down, so all streams were delivered via HTTP, and this enabled us to enable TLS and deliver at least the option for everybody to watch the streams via an encrypted connection, because encrypt everything would be the right thing to do. And this also meant that we didn't need to use Flash anymore, so we totally scratched that. And because we know the hamsters around here, we decided to do everything really required to run our system on the site. So we do all transcoding and all release encoding on the site, and it turned out to be a good idea. And yeah, this was a little different to what we did at Congress. So it was a new thing for us to do everything here. Yeah, we tried to do multicast. Well, we plan to try to do it. But actually, the problem is that with multicast, you're sending out every packet once, and if the device didn't receive it properly, then well, it's gone. So we need some kind of forward error correction on our streams inside the video stream, for example. And we have the code to do that because we're using that on DVB-T too. But it seems there is no device and no program out there able to play that back. So like VLC doesn't do it, and FFmpeg doesn't do it. So if you're working on a media player and want to help implementing forward error correction in the player, so next year we can use multicast, then please talk with us. We would really like some help there. But it isn't actually necessary on the campsite because we had DVB-T here, but at the Congress it might be interesting there. And I think the NOC would like to see some multicast traffic too, wouldn't you?
Yes.
Yeah. Multicast. So yeah, we announced like a YOLO stream, so everyone on the campsite that has anything that makes any kind of noise or sound or music or the like would be able to share that with the internet, but we didn't really get to implementing it, but we will try to do that on the Congress, so be prepared. If you have anything that makes any kind of sound or music or want to share anything, be prepared to stream something to an IceCast gateway on the Congress. We will have a gateway there for you, so so everyone on the internet and on the Congress can listen to what you're producing. Yeah, and that's all from the... Oh, there's a screen from the teletext, actually. So that's all we have to say, and say thank you to the cats, and thank you to all the people. And before you're leaving, we have our local mirror with all recordings of all talks here, and it's connected via 10GE to the Datenklos, so you can start your AirSync now and take all the recordings with you. And yeah, see you soon. Was the other also open with Kugeln? Yeah, it was. Maybe you just do full screen. Yeah, it was there on the view there, but it's not difficult.
Is it something else with the
Oh, see, yeah, maybe it's still at the old presentation.
Get the one?
maybe just doing it full screen would work. Like, clicking this. Yeah.
Oh, that works.
Yeah.
Within it. Yeah.
Yeah. So I should talk to you about the power here at the camp. It was quite a tricky task to do it here. We've started way before the start point set here in March and talked to the big net company here, E.ON Edis, if it is possible to place some transformators outside. But the capacity of the lines here are all not working for us. So you can use it as a museum, but you cannot get any more power. So we started here on the site on the 31st and get to deliver our material and build the backstage. And we've installed a total like 30 kilometers of cables, 224 power distribution boxes. That's only the CE connector ones. So we have about 500 normal connector boxes outside at the whole campsite to deliver you all the power you needed. We've planned with many more power than it's really used. That's the plan of the whole campsite. It was also in the public wiki. And the company that does the sanitary installation here told us they alone would use about 400 kilowatt of power all time. I don't see it, but I think all the showers would be cold, but I don't know it. Total, we had here 7 generators, 5 connection boxes, which we have get the. And instead of a museum building, there was our connection box, and I think it worked fine. The network, the power network. We don't have much problems. We had one generator failure in this morning at the shower spot and the disco. And we had one, burning box. There's some burning RCD in it. It was on, I think, day -1, and we had an defective power line on day 3. So I will come to the statistic later because this computer doesn't have any internet. We had a nice graphics. We'll see it later from the POC. So thanks for the POC for doing it. And we had a whole bunch of angels that helped us here going around, seeing if the cables are not too hot and clicking the RCD back in if you have tried to get it out. And we had a lot of rainproof installation. I don't have to think about so much since the thunderstorm, since we take out all generators and plugging them back in. And mainly all things are working. So some light installation doesn't work, but that's normal. But the whole rest was working fine. So we could. So do we get an image?
Yeah.
So that's the portal of the POC has built for us. You see their live screen of all power that's used from the generators. So I think this one is right out right now, but the rest is live data. And you also have also the live statistics. So mal runter. Ja. So we had one big generator standing at the NOC DC that was able to switch on another generator if we have a power failure. But I think we don't have any failures at the NOC DC, only the big one at the thunderstorm. And also the tents, I don't hear any failures about it. So in total, everything works fine. And if this will work. Yeah, we had. I would like to show you the whole power consumption of the network, but because of the big power failure today and the generator doesn't work, I cannot prepare it, so I don't think I will find it. You can talk to the POCs; they should have it. And yeah, that was it from my side. So I hope it has worked for you and you don't have so much power failures. But yeah, if you have any questions, you can ask them.
Hi.
Hey.
Hi. Einen schönen guten Tag. Dzień dobry. Good evening, ladies and gentlemen. Mam jedno pytanie. Dlaczego tam jest taki kot? Why is the cat standing there?
Ah, okay, yeah, that's an interesting question. Some time ago, the VOC started, when the VOC started to record lectures, we had all things set up, all cameras running, all streams running, everything looked fine, and the hall was empty. So we said, okay, everything's fine, we can go and relax. But then the hall started to fill, and people were standing on the stages, and someone asked, well, why is the stage still empty on the stream? And the thing is that the system in between has failed in a way that it repeated the same frame over and over again, and we didn't notice until the talk started. So we decided we would have something or somebody on the stage who's moving constantly. But we wouldn't get an angel for that dancing all the day on the stage. So we decided to get some cats that are moving all the time. And this is our test if our stream and our setup is working. Because if it don't move, either the battery is empty or the stream is dead. But actually, we're really liking them, so that they're traveling with us to every event, and we really are caring for them. And yeah, we also have a big one at the cube in the office, the mother of the small ones in the tents, maybe.
Hello, I am interested in the reasoning about middle voltage transformers versus generators, and was it no option to install transformers and connect to the global grid? And first this?
Yes, it would be possible. We have, like the NOC said, there was a big transformer station near Selenik, but it would have cost us more money than we had, and it would only be profitable if we do the whole camp for about 1 or 1.5 months. Then it would be okay.
And just another question: why were the showers electrically heated instead of burnt fuel?
Yeah, I would really like to say you why, but I don't know it. I was getting a white piece of paper, and there's then 401.1 kV for the whole shower installation, and I said okay.
Do you know how much fuel was consumed by the generators? How many liters of diesel did the camp need?
I think it should be, we have tanked the last bit today, and it is about 30,000.
Okay, thanks.
How much percentage of the installed capacity was actually utilized by the camp?
Could you repeat it? It was.
Well, you said you have lots of generators, and you had too much power for that. We didn't use enough power. So how little did we use?
So we had here on the camp, we have calculated with 200 watt per person. That would be about, by 4,500 visitors, about 0.9 megawatt. And we had the 400 kV for the installation of the sanitaries. And we had the light and other things, so we planned with about 1.8 to 2.5 megawatt. And we are using right now, I think about, in the highest peak, it was about 500 kilowatt.
Why is the net frequency only 44 Hertz instead of 50?
That's the whole camp. So it is possible that some generators are a little bit lower and some are a little bit higher. So we had to check all generators and it's calculated. I don't know where's the bug. So here we have 49.98 and...
Was that the broken one?
Is the broken one not Hertz?
It's possible that the broken one is not connected right now.
Thank you.
I was wondering, I don't see anyone from the WOC, from the Water Operations Center. Can any of you give us any stats on water consumptions or supplies or whatever?
Maybe they're
Any
still
idea?
drinking.
Right. They're drinking the black water, right?
I think that yesterday the water was empty and we had to get new one, or it was before 2 days. So we've used really much water. No.
First, thanks for all. Everything worked perfectly as intended. Big up, really cool. I would be interested about the costs, actually. I'm not sure if you are allowed to talk about it, but I don't want to see numbers. I just want to know, POC, this 1/3 of the whole budget, VOC, just the technical costs. But maybe it's a secret.
You can talk.
I can talk about this from the NOC point of view. And as we already mentioned, actually, we get a lot of stuff for free from people, or there's not really a market to buy the thing we need. So actually most of our expenditure is on really like ancillaries, how many cable ties and this kind of stuff we have. And on all of our work is done by volunteers, just like other teams. So it turns out that it's not that expensive from a network point of view.
Well, you saw the minions, the small boxes we have to encode the video, and we have those new since the last Congress, but they are not only for the camp here. So we will use them at a lot of the small conferences of the CCC and also assorted conferences and meetups all the way down. So even if they count, maybe I don't know really how from which budget they are calculated, but even if they count to here, they are not gone at the end of the camp. So we will use them for the next years to do what we're doing without any charge to small conferences.
Yeah. At my point, I cannot say, I don't know the whole budget here, so I think it's really a big part of the whole budget for the electrical installation, because it's so much. It's the diesel or Heizöl that we are using here. It's the generators, but you need it because you don't know how many people you will get. Some villages said they need 63 amps only for them. They don't use it right now. So I think it's quite a big part, but yeah.
Are there any more questions? Well, then give a warm applause to all the people working here, all the angels helping out.
So a really, really big thank you for all the figures, all the interesting stuff and interesting information. This is for the infrastructure review. And so please also a really big round of applause for Will, Arjen, Mastermind, and Fengel.